Today we're looking at using a result type to handle errors. The result type is a generic that takes a value of t and type of e, which is the error, and it's an enum. It gives you these two properties. I'm not sure if they're called properties in Rust or not, but I'm going to call them properties for now until I figure out if that's really what they're supposed to be called. There's a method on the enum. This is when you do get the value successfully. Whether there's a success or failure, it doesn't cause the app to explode, like go into panic mode, because we have the error encapsulated in this enum. It's a nice way to get the error and figure out what you want to do with it. In contrast to the option type, which describes the possibility of the absence of a value, the result type is best suited whenever failures are expected. I feel like right away network requests would be using the result type based on that. The result type also has the unwrap and expect methods, which do either of the following: return the value inside the OK variant, cause the program to panic if the variant is an error. Let's see result in action. Let's look at some code. There's this division by zero error, which is a struct which they were mentioning. And we have this function called save division. There's a dividend and a divisor for doing the division. The result is a floating point 64 with a division by zero error. If the divisor is equal to 0, we give a division by 0 error. Otherwise, we say dividend divided by divisor. And then we can print this out with the different examples. We can go try this out in the playground. If you haven't checked this out yet, play.rust-lang.org is the playground. They returned a value of 3.0 because 9 divided by 3 will give us 3. 4 divided by 0 is just not happening, so we're getting this error, division by 0 error. And then 0 divided by 2 is giving us 0. That all makes sense so far. And that's the output that we got. This is what I'm curious about. The derive debug part that precedes division by 0 error struct is a macro that tells the compiler to make the type printable for debugging purposes. We'll cover this in depth later in the traits module. We're going to use the result type to handle errors. In this exercise, you'll replace the to-do macro inside read file contents to make it compile and run without panics. Before this challenge, here's some things you need to know. Read file contents is a function that receives a path buff struct, as it's a single input and returns a result of string or IO error. It does the following in this order. It creates a new mutable and empty string. That's because we need to fill in what comes through the path buffer from reading the file, I guess, and it'll just populate the string so we can return it in the result. That makes sense, and it's going to use the read to string like it's saying, and it returns the modified string. We've got to replace these to-dos. I like the to-do macro. I'm not sure if it compiles with it, but it's a nice way to explicitly say you got to do something here, instead of just a to-do comment, which is like, yeah, maybe I'll get to it, maybe I won't. I'm going to copy it, and I'm going to paste it in here. We're going to read file contents. So path is of type path buff, which is most likely reading in a file. I'm just trying to see where it gets called. Okay, source main.rs, non-existent file. If you plan to complete this exercise on the Rust playground, understand that by using the playground, you can read your own code as a file named source main.rs, which is its own virtual path. It's going to assume that this is source/main, so I don't have to worry about that. Cool. We're going to assert that reading in the file contents from this virtual file, which is the contents in the playground right now, is okay. Otherwise, it returns an error because this is a non-existent file text. For those who might not have been on the streams previously or who haven't done any Rust yet, all the variables in Rust are immutable by default. If you want to make something mutable, you have to use the keyword mut here. That indicates that this string is mutable and that we'll be able to manipulate it getting the file contents from things there. The first thing, handle this match expression. This is saying here, file here is a type file, and we're making it mutable. We're saying we want to match for an open file here. And if it matches a file handle, that's okay. We need to do something. Otherwise, it's an error and we need to do something. I want to see what it's saying. For the to-do-one, the OK value case must provide that inner value, and the error value must be returned from the read file contents. If that's the file handle, I have to read the file. I guess this is it. Read file contents, string new. I'm wondering how to get the value. Oh, file.read to string. No, okay. Pass the variable to the file variable on success. I need to return the value from this, but it's not. Oh, I guess maybe it's this file handle. It would help if I go to the actual playground because I'm typing on a browser page where I can't delete it. I guess maybe it's this because this is the value. And put a comma. And then here, I guess we got the error, so the IO error. If it's okay, the success path is already filled in for you. Return from the function early if it is an error. Let's run this to see where we're at. It's going to give some errors, but I want to see. Match arms have invalid types. Oh, wait, I have to do result. This is where I'm confused. Pass a variable to the file variable on success. Okay. Or return from the function early if it is an error. Pass the variable to the file variable. This is the file handle. I would assume that this should be good, but this one's saying expected struct file. So this is a struct. I believe this is how you do it. How is the file struct work? I'm gonna look this up real quick. Rust file struct. I'm not returning the proper type. This looks somewhat better. Let's go back here for a second. So file open. Let's try this again. We're opening it. So what am I missing here? It's a struct of type file. I'm trying to figure out how I return the value here. It's something super silly, I'm sure, because the match is going to fill this variable here with the value. This is the file handle when it's successful and it's matching because we did the file open path. I feel like it's just supposed to be file handle. This isn't going to work right now, but I'm going to comment this out. Let's run this. It's going to tell me that they're not compatible types again, but I want to see the error. This is one thing I keep talking about for Rust is it's so verbose in terms of the errors. This is literally saying run this command and I'm going to explain to you what that error is. I do understand the problem here. It's because it's not matching the type and it's a compiled language, so the type is not matching. It's normal. This should be fine, the file handle. I'm just trying to figure out how you return an invalid one. So return from the function early if it is an error. I'm not sure how to do that because I don't want to throw the error. Interesting. Let me go check in here what it's saying. Is okay. No, that's not what I need. IO error read. Okay. I can't return that. Oh, I need to, yeah, I can maybe see I can't even do this here because if I do file, the success path is already filled in for you. If it's okay, yes, IO error. Nothing like struggling in public. Result. No, it's going to be the same thing here. Mute string file dot read to string mute. The success path is already filled in. You return from the function. I'm getting a little lost here. I get this here that it's not matching, but what is going on here? Maybe I'm just having a case of the Fridays. It says pass a variable to the file variable on success. I'm pretty sure that's good. It's more when there's an error, like what am I doing here? I don't want to, if I throw the error there because the file doesn't exist, I don't think I want to do this, but maybe. Let's just see here. Unused variable IO error. Oh, down here. The first part seemed to do okay, and I guess you want to panic here. Well, I don't feel like panic's good, but we'll move on anyways, and we'll see. That's good there. Now we're gonna read in the string. That's gonna be the value. We'll say, let's go file contents. From there, it's going to say, what was that called up here? Much string. I want to do string dot push str, I believe. File contents. Is that right? String new, string dot push str. I think that's okay. Read to string and much string. Cool. Now, if there's an error, I'm gonna do this again here. It's not what I want to do, but baby steps, figure it out. And then return the string variable as expected by this function. In that case, like we've learned in Rust, you don't need to use return explicitly if it's the last thing. We're going to say return string. I'm going to run this. And let's see here. Expected ampersand str. Maybe I'm doing that wrong. File contents. Is it this maybe? I will check the solution if not in a bit. Okay. Read file to string. This expression has type result usize stdio error expected usize found reference. Borrow is when you're doing the reference, I guess. And I'm not sure. I could have sworn it's push str. Maybe I need to. We know these bytes are valid, so we'll use unwrap. I don't want to get in the weeds here too much, but string from. I wonder if that'll work. Let's go check that out. Let's try string from. Let's run that. The trait from usize is not implemented for string. File contents. Mismatch types. Gonna give it one more go here, and then I think I will look at the solution because there's something I'm not getting. I'm gonna go back to the exercise and maybe they talk a bit more about the file system in here. Read file functions is a function that receives path buff as string. So it's a buffer. The function does the following. Tries to access the file path, tries to read the contents from the file into the string you just created by using read to string. Yeah, I get that. Value must provide that inner value that I was doing. And the error value must be returned early from the read file contents function. Expects you to handle the error case as you've done in the to-do exercise number 1. Why can't I add? It's related to, I think this here is a buffer. I'm wondering if I need to read it from UTF-8 here. Could be wrong. I might be getting in here too deep. Mismatch type expected, struct vect found. Size. Okay. There's clearly something I don't know about reading the string from a file or converting it to the buffer. I'm going to take a peek here at the answer. I have to return. First thing I did wrong here, if we come back, I was thinking of this like JavaScript where you don't need to do the explicit return. I was also doing panic, which we don't need to do. And in the case here, I need to return here as well. I think that makes sense. Okay. Handle this error. Let's go back here. I don't understand what they mean by the success path is. Oh, I get it. I didn't even have to change this. It's already read the file. It's fine. That match is fine. It's only if there's an error. But I'm still kind of confused. Okay, let's update the code on my side. This has to be return error. Because the result type is string or IO error, when you return here, it knows to construct that properly. I need to do return error, IO error as well. This is what was tripping me up. I thought I had to modify something here. I know it said the success path is already filled in for you, but to me, this didn't make sense, but it does now that I'm looking at it. It took me a while to wrap my head around this. We're doing a file read to string, and we're filling in the string, which is our mutable variable up here. That's what threw me off. I for some reason thought this was actually supposed to be returning a string. It's in fact populating the string, and that's why we can return it explicitly. I know I took a peek at the solution. I wasn't understanding something, and I'm here to learn something, so honestly, I'm not sweating it too much. I'm going to re-explain from what I understand here. It took me a second to understand this, but it's okay. You know, things don't always come automatically, and that doesn't bother me. I'm just trying to learn. Here's our main function, and we have this function called read file contents, and we're gonna read in a file from source/main.rs. We're in the playground, which does not have a real file system because I'm in a browser. From what it said in the documentation with the playground, the file, the area we're working in right now, where all this code is, gets treated as a virtual file called source/main.rs. That's why we're able to read that. And we would expect this to execute correctly. The second one we have here is we're reading the file contents again, but from some non-existent file, which should give an error. That's what's supposed to happen. I like repeating things so it sinks in. We're reading in the file contents. This is the file that we want to work with, and it's going to return. This is the syntax for saying this is the return type here. We're returning a result type, which is either going to contain the file contents as a string if it gets read in successfully, and it can also have the IO error if there's IO errors. As I mentioned, variables in Rust are immutable by default. If we want to manipulate a variable, we have to explicitly give it the mutable keyword. We're saying we want to make this file variable mutable, and it's of type file, which is a struct, which appears to be a standard, which makes sense in the standard library for Rust. That's coming from here, standard fs file, a struct. We're going to open the file. We're going to say, open this file, and I want to match its result to one of the arms in the pattern matching. If it is able to open the file, we're going to get an OK here, and this is the file handle, and we will return the file handle to the file variable. If there's an error, we're going to return early with the error. And then we move along. At this point, we have a valid file handle. We're going to read its contents to string, and we are going to populate the string variable that we set up at the top here, the mutable string here. That's going to get filled with the file contents. If it's successful, we don't need to do anything. Think of this as an empty function. It's like I matched here, but I don't need to do anything. If there's an error, we get the error here, the IO underscore error, and we return that error. If everything goes as planned, we're at the end here. We've successfully read the file contents, so we return the string variable. I'm going to rerun this now. Hopefully everything should be good. Interesting. Expected result type string std error because of string. Okay. Weird. I wonder. Oh yeah, sorry, I didn't do the to do. So this should be result. I guess I do it like this. Okay, string maybe, and then error. I don't think this is right, but let's try that. I didn't do that right on the return here. The return the string variable is expected by this function signature. I don't understand why it didn't like returning the string here. The only thing I'm a little confused about here is the return value is a result of type result string IO error. Here we return early. Oh, I know what I need to do. I need to return OK here. I think that's what'll do it. The reason why I'm returning OK is because if we come back here, up at the top, we have to do the OK value or error value. If we come back into here, we're returning the error, IO error here and up there. I needed to return OK string. Let's run that. I think this will work. Feeling pretty good. Nice. And for fun, we can do a print ln, and let's do file contents, and we'll say string. As I've mentioned in other streams, you definitely have to put semicolons. It does not compile otherwise. I was able to print out the file contents. That's just validating that it really does work. I feel pretty good about that. I feel like a couple of these concepts, it's taking me a little longer to click maybe, but you know, it's all good. Let's just kind of go over what this module covered. This includes work we did yesterday and even maybe a bit in the first one. So we know how to halt a Rust program now. You can use the panic macro. And that's really something you use when it's game over. You got to shut down your app. It's something's toast. The other thing we did was the result type just now. We also covered how to use pattern matching. Option and result type are the peanut butter and jelly of functional programming. Well, I guess we just made a sandwich, Kirk. All right, let's go to the next module. Understand how Rust manages memory. I haven't really worked extensively with a language where I need to manage some memory. I think this will be potentially challenging. We'll see. What are we going to learn here? There's this concept of ownership in Rust. There's moving and borrowing of values, scoping rules, and lifetimes. Let's go to the intro. And side note, I do find this is a pretty good course so far. I'm enjoying it. We're going to look at ownership and borrowing now. And so these are features that enable Rust to make memory safe guarantees without needing a garbage collector, unlike many other languages. This is interesting because from my C++ knowledge, which is pretty non-existent now, you literally had to manage all the memory yourself. If these things are able to allow you to manage memory pretty easily and not use garbage collection, I'm pretty interested. What is ownership? In Rust, memory is managed through an ownership system, which is a set of rules checked at compile time. None of the ownership features slow down your program while it's running. To understand ownership, let's first take a look at Rust's scoping rules and move semantics. That's a lot of big words, folks. Like most other programming languages, variables are valid only within a certain scope. That makes sense. You have block scope stuff like in your if else, or even just a block in JavaScript. That's how const and let work as well in JavaScript. I'll be making a lot of comparisons to JavaScript or TypeScript, occasionally C# because those are pretty much the languages I've worked in. Common scopes include function bodies, if else, and match branches. Okay. In Rust, variables are often called bindings. This is because variables in Rust aren't very variable. They don't change that often since they're immutable by default. Instead, we often think about names being bound to data, hence the name binding. But we'll use both interchangeably, variable and binding. It's always good to kind of know the nomenclature. We've got a mascot variable here, and its immutable value is Ferris. Mascot is valid from this point forward. It's valid because it's immutable, so it's like it's Ferris all day, all long. Since it's in a block, the scope is now over. It's no longer valid and cannot be used. Now, we try to use mascot beyond its scope. This error makes complete sense because the mascot is not available in this scope at this point because it was within the block here. Scoping rules. Okay, so that's just a scope. That's pretty common in programming, scoping, ownership, and dropping. Rust adds a twist to the idea of scopes. Whenever an object goes out of scope, it is dropped. Dropping a variable means releasing any resources tied to it. For variables of files, this means closing the file, and for variables that have allocated memory associated with them, this means freeing that memory. In Rust, bindings that have things associated with them that they will free when the binding is dropped are said to own those things. In our example, the mascot variable owns the string data associated with it. The string itself owns the heap allocated memory which holds the characters of that string. At the end of the scope, mascot is dropped, the string it owns is dropped. Finally, the memory that string owns is freed. This kind of sounds like, well, it's not garbage collection because garbage collection waits. This is almost like instead of the garbage truck doing the route of the whole neighborhood, it's like as soon as you put out trash, the person's there and takes it. I don't know if that's a good analogy or not. The garbage person on demand. Move semantics. Sometimes, though, we don't want things associated with a variable to be dropped at the end of the scope. Instead, we want to transfer ownership of an item from one binding to another. The simplest example of this is when declaring a new binding. Let Ferris equals mascot. Ferris now has the same reference to the Ferris string. So transfer ownership of mascot to the variable. And it says Ferris dropped here. The string data memory will be freed here. Why is it saying Ferris dropped here? The string data memory will be freed here. I would assume it would be freed up once you're out of the block, or maybe I'm misunderstanding what they're saying here. A key thing to understand is that once ownership is transferred, the old variable is no longer valid. That's interesting. Ferris equaling mascot, it's a reference to that same string, but mascot is no longer valid. We can no longer use the mascot variable. Now, instead of having to manage two pointers to that object, it's only one at that point. If we try to use mascot after the string has been moved from mascot to Ferris, the compiler will not compile our code. Let's go to the playground. But we always have to have a function main here. Let's run this. It's supposed to error out here. Warning, unused. Let's do this. Let's do Ferris so it doesn't give us that compilation error about unused variables, which again, I'm loving the Rust errors. It's almost like linting built in as well. This thing isn't used, like, do you really need it? It's saying borrow of moved value mascot. Move occurs because mascot has type string. which does not implement the copy trait. We haven't talked about traits yet, but it's saying the value moved here, value borrowed here after move. If I comment that out and run, it should say Ferris. It makes sense to me and it doesn't at the same time. If this is the way things in Rust work, then that's just the way it works. Again, I think this is a trivial example because you probably wouldn't write code where you say set some string to some variable and then set that variable to equal a new variable and all of a sudden the old one's invalidated. Let's keep going here. This is what we just saw. This is known as a use after move compile error. Okay. Okay, so that makes sense. If that's the way Rust does things, as long as we remember that. Even if we don't remember it, honestly, the compiler is going to tell us very explicitly. It bears repeating, and we will repeat it because I want it to sink in. In Rust, only one thing can ever own a piece of data at a time. This ties into at the start of the course where it says you can't have race conditions because only one thing can ever own that piece of data at a time. It has race condition prevention built out of the box just because of this. Ownership and functions. Let's take a look at an example of a string being passed to a function as an argument. Passing something as argument to a function moves that thing into the function. I have function process input of type string. It's not doing anything, but this is a function. Then caller, let s. We want to read in the string hello world. We're going to process it. The ownership of string in s is moved to process, which means the parameter input here is going to be the owner at that point. After that, we get an error because we can't process it again because the ownership is transferred. Let's go into the playground because I want to try something after. Okay, so I'm going to run this just so we see the errors. We run this here and we've got the error input type string is not being used. Let's do this for now. Print ln and we'll do input. Let's build this. It must be a string literal. Okay. Just trying to think what we can do. This input string is going to look silly, but I'm not sure how to process it at the moment. It's still giving an error. Let's do this. I'm going to say return the input, which is, it makes no sense here, but I'll get to what I'm talking about here. This is still going to give the error ownership is already moved error. And I'm going to remove these comments because it's clouding the actual error. Let's run this again. It's talking about the move here. Let's read through it again here. I'm setting s to hello world. As soon as process takes on s, process is now the owner. Since it's the owner, the input here within the function process becomes the owner. Once we're done here, there's nothing else we can do with s, which is why we do that value use here after move. What I'm thinking of doing is I'm just returning input right now. If we were to do this, which obviously this does nothing, but we should not get this error now because process s is going to return the reference to that string. Then the second process is now going to become the owner of what was originally owned by s. This shouldn't give an error. Maybe it does. Expected struct string found. I didn't think I would have to explicitly do this, but let's try this. Expected struct string found implicitly returns as its body has no tail or return. I thought I didn't have to explicitly do a return. Maybe there's something I'm missing here. Let's do this. Function process. Warning, function is never used. This has nothing to do with the concept of borrowing. I was trying to see if I'm returning the input again, then that input gets passed into the next process. That doesn't seem to do it. Function is never used. Caller. This is me getting tripped up in the playground. I don't have a function main. Let's call this main. That's what I was expecting to see. We're going to say Print ln new owner. This should print twice. New owner, new owner. I have a feeling that the playground is going to die here. Oh no, timed out. Let's try again. I wonder why it times out sometimes, because I feel like the compiler is probably running in the browser, maybe with WebAssembly or something. I don't think it's actually going back to their server to do it, but okay. The ownership concept is pretty interesting. It's just complaining about the value being moved. Let's go what it says here, because this sounds important. This pattern has a profound impact on the way Rust code is written. It's central to the promise of memory safety that Rust proposes. You only ever have one owner, so only that current owner can do something. In other programming languages, it says the string value of the s variable can be implicitly copied before being passed to our function. But in Rust, this does not happen. In Rust, ownership transfer, that is moving, is the default behavior. So there's only one owner. Things are immutable. These are interesting things to keep the language pretty solid, I think. Copying instead of moving. You might have noticed that in the rather informative compiler error messages, yes, they are quite informative, the copy trait was mentioned. We haven't talked about traits yet, but values that implement the copy trait don't get moved, but are rather copied. We're probably going to finish up with this today. Let's take a look at a value that implements the copy trait, U32. The following code, which mirrors our broken code from above, compiles without issue. So we've got a U32, number 1, and this is explicitly saying it's a 32-bit signed integer. You could say n colon U32 as well. We're going to process it. Ownership of the number in n is copied into the process, and then n can be used again. This is what is the default in pretty much any other language I've worked, I believe. So simple types like numbers, copy types, they implement the copy trait, meaning they're not moved but copied. This is the case for most simple types. Copying numbers is very inexpensive, and so it makes sense for them to be copied. Copying strings or vectors or other complex types can be quite expensive, and so they do not implement the copy trait and are moved. Makes sense. Copying types that don't implement copy. One way to work around the errors we saw above is explicitly copying types before they are moved, known as cloning in Rust. A call to clone will duplicate the memory and produce a new value. The new value is moved, meaning the old value can still be used. Let's look at this. A function process taking an input of s for the type string. In our main, we're saying use it again. Then in the first process, we're cloning it, so we haven't passed the ownership yet. In the second process, it's used and it's the new owner. If we were to call process s again, then that would give that error. It says this approach can be useful, but can make your code slower as every call to clone is making a full copy of the data. So it's a deep clone. This often means performing memory allocations or some other expensive operation. We can avoid this if we borrow values using references, the topic of our next unit. I think I'm going to stop here for today. I like ownership in moving. Even if at first you're like, that doesn't make sense, I guess once you just start writing Rust, you're like, well, that's just how we do it, you know?